Hello everyone, how is everybody doing today? Well, in this video I'm going to calculate, the infinite volume that is generated by this curve, e to the negative x, when it is revolved about the y-axis. So suppose you have, Cartesian plane, x, y, and then we have e to the negative x, It falls like that, so this is going to be the function. And so what we want to do is we want to revolve the area, We want to revolve this area in the first quadrant below the curve and above the x-axis around the y-axis. So we want to rotate it around the y-axis, right? Which means that the radius will be like that, right? So this will be r of y, And to find r of y, we have to find the function in terms of the variable y. So we take ln on both sides, and we get ln of y is equal to, ln of e just cancels out, so we're left with negative x. And x equals negative ln of y, which is also equal to, according to the logarithmic rules, ln of y to the power of negative 1, or ln of 1 over y, So that will be our radius function over here. But of course, we want to square the radius and multiply by pi, right? And then we're going to add up all those little, disks, those infinitesimal disks, with radius r of y from this point to this point, right? But as you can see, this curve will never touch 0. So that's why it is, an infinite volume. And it's kind of like a weird concept, but, it's good to think about it. I mean, this function is always decreasing. So it's going to be so close to 0 at infinity, but it will never reach 0, right? So at some point, that volume that you're going to get at infinity, will converge to some value. So we're going to go ahead and define our volume function in terms of y. So volume, this is volume of revolution. So it's going to be pi times integral from a to b of the radius function squared dy, Now we're integrating from here to here. What is the intersection over here? Well, if we let x equal 0, y equals 1, right? E to the 0 is 1. So that's going to be 1 over here. So we're going to integrate from 0 to 1. Now, but here is the catch. At 0, it does not, it is not bounded. The curve is not bounded. So we have to take the limit, of this function as it goes to 0. So the lower limit has to be defined outside of the integral. So we're going to say that this is also equal to, the volume is equal to pi integral, but of course we're going to evaluate it as a limit. So we're going to say this is pi times the limit, of the integral from a to 1, right? As a approaches 0 from the upper side, so from the positive side, so 0 plus, limit as a goes to 0 plus, integral from a to 1 of ln of 1 over y dy. And this is going to be squared, right? Now we can evaluate the integral, And as you can see over here, we can use integration by parts. So let's try our u to be ln of 1 over y squared and dv to be dy. So let's use integration by parts, but I'm going to use, of course, the di methods, which is the fastest way to do it. So our u over here is going to be ln of 1 over y squared, and our dv, will be dy. And of course, we are going to alternate the signs. So the first one is positive, the second one is negative, the third one is positive. So let's see what we get. If we differentiate this, we have to use the chain rule, 2 times. So what's the derivative of the inside over here? That's going to be negative 1 over x squared, right? The derivative of 1 over y will be negative 1 over y squared times the derivative of the outside of the inside, which is going to be the derivative of ln of y over ln of 1 over y, which is 1 over 1 over y, right? So that's going to be times 1 over 1 over y. And then we're going to take the derivative of the outside. So we bring the 2 down, right? So that's going to be times 2, and then times the original, ln of 1 over y, As you can see over here, we can cancel out a y, And then over here, the integral of dy will be y, okay? So we're going to do the following. We're going to multiply this, cross multiply it, and then we're going to integrate what is left. We're going to integrate u dv, right? Because this is integration by parts. So the integral of this equals to u times v, right? Minus the integral of v du, okay? So we're going to have something like this now. We're going to cross multiply over here, and we're going to have that this is equal to the integral, okay? So we have to evaluate it as a limit. The limit as a goes to 0 from the right? And negative times negative is positive. And this y cancels out again. So we're just left with this expression over here, which is going to be, let me put a bracket. This is going to be ln of 1 over y squared times y, right? And then negative times negative is positive, so that's going to be plus integral, okay, from a to 1 of 2 ln of y, 1 over y. So 2 ln of 1 over y dy. And then we can integrate this by parts once again. Okay, let's use the di method now once again. So let's set our u to be equal to 2 ln of 1 over y, and our dv to be d1. Okay, so u is going to be 2 ln of 1 over y, and dv will be dy. Okay, now we alternate the signs. This is positive, negative, positive. And over here, the derivative of this would just be 2 times 1 over y, right? So, and this over here will be, but of course over here we have to use the chain rule. So you have to multiply by the derivative of the inside, which is negative, okay, times negative 1 over y squared. The integral of dy is just y, okay, so we just cross multiply. This times that, u times v, minus the integral of u dv, which will be this. Okay, but look at that. This one and this one cancels out once and then twice. So we're just left with negative times negative is positive, 2. So we're going to have something like this. We're going to have that this, okay, over here. Let me just erase. That the integral, okay, is going to be equal to, okay, the volume will be equal to the limit as a approaches 0 from the right of ln of 1 over y squared times y plus this integral over here that we just did, which will be 2y ln of 1 over y, and then plus integral of 2 dy, okay? And of course, integral of 2 dy from a to 1 is just 2y, right? So we're going to have volume is equal to the limit as a approaches 0 from the right of ln of 1 over y squared y plus 2y ln of 1 over y, and then of course plus 2y. All of that evaluated from a to 1. Now over here, let's see if we can evaluate the 1 first, right? So if we plug in 1 over here, right, in this ln of 1 over y, it's just going to be ln of 1, which is 0. So that goes to 0. This one goes to 0 as well, and this goes to 2, right? Oh, and don't forget the pi. The pi, okay, is multiplied by pi. The volume is multiplied by pi, right? So it's pi r squared, integrated from a to b, from a to 1. Now, this is going to be equal to, okay, the limit as a goes to 0 from the positive side, okay, of, now we said that this was 0, evaluated at 1. This was 0 and this was 2, right? So it's 2, and then of course the pi goes outside, minus the expression evaluated at a. So this is going to be something like, okay, ln of 1 over a, right, squared times a, and then plus 2 times a, ln of 1 over a plus 2a, okay, evaluated okay, at a. So, but now we're going to take the limit. So if we take the limit from the positive side, okay, as a approaches 0 from the positive side, you're going to see that this approaches infinity, right? Negative infinity. But it also is being multiplied by 0. So essentially what's going to happen over here is that it will be a very large number, right? It will be an extremely large number, but it will be multiplied by 0. So anything multiplied by 0 is just 0. So that just cancels out, that goes to 0, and this also goes to 0. For instance, 2 times 0 is 0. So we're left with 2, right? So we can say that the volume, okay, the volume is equal to 2 times pi. Okay, so the volume converges to 2 times pi. Because we cannot say that it is exactly, that value, since we're looking for an infinite volume. That's a weird concept. But of course, we can say that it converges. It approaches this value over here, which is 2 pi, okay, squared unit, cubed units, right? So yeah, that's a pretty interesting problem. Anyways, thanks for watching. Make sure you subscribe, share it with your friends, and check out my Patreon page, okay, Marin Maths. And I'll keep posting videos. Watch out for the common exams that are coming up. I'm going to put some calculus and physics common exams. And hopefully that's useful. Good luck on them. I'll see you next time.